Hello, welcome you all. Today's topic is Echelon Form based method to compute the rank of given matrix. So this is the another method to find the rank of any given matrix. So a matrix A is said to be an echelon form if these three conditions are satisfied. The first condition is not a necessary condition, so we may relax this condition in some situation, which is the first non-zero entry in a row should be unity if possible. If possible means we do not require to satisfy this condition in every case. So the second condition is all the non-zero rows, if any, precede the zero row, which means that if there exists any zero row in given matrix, then that zero row must be placed at last, that is bottom of the matrix. And the third condition is the number of zeros preceding to the first non-zero entry or before to the first non-zero entry in each row increases row by row until only zero rows remains. These two conditions are actually necessary conditions. So in order to verify that whether any particular form is an echelon form or not, we have to satisfy these two conditions. So suppose a matrix A is reduces into echelon form, then the rank of that matrix is actually calculated, and which is same as the number of non-zero rows in that reduced echelon form, or in general this reduced echelon form is known as row reduced echelon form, as we are actually reducing the rows of given matrix into echelon form. So suppose we have to verify that whether this matrix is an echelon form or not. So we have to mainly focus on these two conditions, that these two conditions are necessarily satisfied for any given matrix in order to say that it is in an echelon form. So the second condition is all the non-zero rows, if any, precede the zero row. This is non-zero row, this is non-zero row, and this last row is actually zero row, which means that all the non-zero rows are actually placed before the zero row, or zero row is placed at last of the matrix. So second condition is satisfied. Now to verify the third condition, we have to find the number of zeros before the first non-zero entry in each row. In the first row, this entry is actually first non-zero entry, so before this first non-zero entry the number of zero is 0. In the second row, this is our first non-zero entry, and the number of zeros before this first non-zero entry is 1. So in first row, number of zeros before the first non-zero entry is 0, and in the second row the number of zeros before the first non-zero entry is 1. It means number of zeros are increasing row by row until we have only the zero row. So the second condition is also satisfied. Therefore this matrix is our in echelon form, hence its rank of this matrix is actually number of non-zero rows. This row is non-zero row and this row is non-zero row. So the number of non-zero rows is 1 plus 1, that is 2. Therefore rank. Suppose we have to find the rank of this matrix by reducing it into echelon form. So we have to reduce this matrix into echelon form, in which in general the second and third condition of echelon form are required to be satisfied. So the second condition is if there exists any zero row, that zero row must be placed at last, that is must be placed at bottom of the matrix. Here all the four rows are actually non-zero rows. All the four rows are non-zero row, so the second condition is by default verified since there is no zero row. Now to verify the third condition, the third condition is that suppose in the first row this entry is non-zero entry, here the number of zeros before this non-zero entry is 0. So echelon form, at least we have to transform the second row in another row in which the number of zero before the first non-zero entry must be at least 1. So this entry is reduces into 0 in order to show that that form is an echelon form. If there is 1 0 before the first non-zero entry, then in next row, that is in third row, at least 2 zeros are required before the first non-zero entry, and in the last row at least 3 zeros are required in last row before the first non-zero entry. So convert this in order to convert this matrix into echelon form, the following operations are adopted. In the first step, we have simply replaced the second row by R2 minus R1 so that this entry become 1. Now interchanging the first row and second row, so we can find 1 in this place, that is the first non-zero entry. If possible, it should be 1. So here we have satisfied the first condition, 1, that is this first non-zero entry in first row is reduces into 1. So here 1 is reduces. So with the help of this one, our objective is to reduce all these 3 entries into 0, as we have to increase the number of zeros before the first non-zero entry in each row, and the number of zeros must be increased row by row. So therefore, in order to reduce this entry into 0, we have to apply R2 minus 2R1, and this entry into 0, we have to apply R2 minus 3R1, and this entry into 0, we have to apply R2 plus 2R1. So therefore, in first row, now the first row, the number of zeros before the first non-zero entry is 0, and in second row, the number of zeros before the first non-zero entry is now 1. These two rows are in echelon form. But in next case, in third row, if we find the number of zeros before the first non-zero entry, again here the number of 0 is 1. In second row, there is one zero entry before the first non-zero entry, and in third row again there is 1 0 entry before the first non-zero entry. So in echelon form, we have to convert this third row in another row such that at least 2 zeros are required before the first non-zero entry. So our objective is to reduce this entry 17 into 0 with the help of some suitable operation. So mission is R2 plus 2R4. If we apply the operation R2 plus 2R4, then this entry becomes 1. So in this case, we have transformed this entry 13 into 1, as we have to utilize this entry to reduce these two entries into 0. So we have adopted this operation. So with the help of this one, this entry has to be reduces into 0, and this one also. So this entry is converted into 0 with the help of this operation, and this entry into 0 with the help of the operation R4 plus 6 times of R1. 6 times of R1. So we obtained this form. Now the first non-zero entry in first row is 1, and the first non-zero entry in second row is 1, and the first non-zero entry in third row is minus 74. The number of zeros before this first non-zero entry is 0, here 1, here 2. Again in last row there is again 2 zeros before the first non-zero entry. In third row there is 2 zeros. So in order to reduce this matrix into echelon form, we have to involve at least 3 zeros before the first non-zero entry. So our objective is to convert this 30 into 0 with the help of this entry and using suitable elementary transformation. So for this, we have to first adopt this operation so that this entry is reduces into 1, and with the help of this one, then this entry is reduces into 0. Now this form, as you can easily see that this form is our row reduced echelon form, as all the rows of this matrix are in echelon form. This first condition is the first non-zero entry in each row should be unity if possible. So this condition is not necessary, so we can relax this condition for some rows. So here if you want to simplify it further, you can divide the last row, that is fourth row, can be replaced by 1 over 286 into R4. So this entry becomes 1. Now the second condition is the number of zero row. The zero row must be placed at bottom of the given matrix. Here all the rows are non-zero row, so the second condition is by default satisfied. Now the third condition is the number of zeros before the first non-zero entry in each row should be increases row by row. Here the number of zero is 0. Here the number of zero before this non-zero entry is 1. Here number of zero is 2. Here 3. That is number of zeros are increasing row by row before the first non-zero entry. So this form is our echelon form, and then if given matrix is reduces into echelon form, then its rank is actually the number of non-zero rows in that reduced echelon form. Here the number of non-zero rows are 1, 2, 3 and 4. So therefore the rank of given matrix is 4.